The Linux kernel of many popular operating system distributions contains 200 to 500 million lines of code. The average user never touches many of the libraries that are contained in these operating system distributions. For example, if you spin up a virtual machine on a cloud service provider, the virtual machine will have a USB driver. This is wasted space because you can't even interact with the USB port on a virtual machine. Unikernels are a way to rethink our usage of operating systems. A unikernel uses a stripped-down operating system called a library operating system, and it contains only the libraries that you need for the applications that you are running. Today's guest, Scott Weiss, joins the show to talk about unikernels, and a project he is working on today is called UniK, a tool for compiling application sources into unikernels. And we will get into what that means, how unikernels compare to Docker containers, and many other topics. Before we get to the episode, a few quick announcements. Software Daily is a project that our community is working on. We're building an open source news and information site about software. And if you are interested in contributing to that, check it out. We would love to have developers, particularly if you're familiar with React.js or Node.js. And also, if you want to sign up for the Slack channel, if you want to email me, if you want to send me a tweet, if you want to tell me what I'm doing wrong, what I can do better, what I am doing well, please send me an email. And also sign up for our newsletter, Software Weekly. It's a great short newsletter that comes out once a week with some great curated content. It's not annoying or offensive. It is a treat to find in your inbox. And with that, let's get to this episode after a short message from today's sponsor. Illuma is your data pipeline as a service. With Illuma, you can create custom analytics with Amazon Redshift. Illuma is a fully managed tool for pulling from different data sources: MySQL, Postgres, Elasticsearch, Salesforce, many others. The code engine of Illuma allows you to write custom Python code over the data stream to clean and enrich your data, and the mapper allows you to control how your data is loaded to your data warehouse. If your schema changes, use the auto mapper to handle that change. To find out more about Illuma, go to illuma.com/sedaily. With Illuma's custom analytics, you have a holistic end-to-end view of your business. Join your marketing data with your Salesforce data, for example, and discern the true value of your online marketing campaigns. Go to illuma.com/sedaily to find out more. That's illuma.com/sedaily. Thanks to Illuma for being a sponsor of Software Engineering Daily. Scott Weiss is a committer to UniK, a tool for compiling application sources into unikernels. UniK is spelled UNIK. Scott, welcome to Software Engineering Daily.
Thank you, Jeff.
So let's start off by talking about user space and kernel space in a typical operating system. This is kind of a fundamental concept to operating systems, but I think we should cover it before we get into unikernels more deeply. So explain the difference between user space and kernel space in a typical operating system.
Basically, the way this works is operating system has certain access to low-level parts of the operating system, has control over users, access to hardware, and it limits the access that applications can have. So applications run in user space, and then the operating system runs in kernel space. And it's basically a privilege separation to add some security. So when a user application wants to access something that the kernel mode is required for, it will make a system call to the kernel in order to acquire those privileges.
So is the separation between user space and kernel space, this is mostly for security, or it's entirely for security? Are there any other functionalities to the separation?
To be totally honest, I'm not an operating systems programmer. I couldn't tell you if there are other features, functionality to it. Okay. But basically, there are certain processes, certain calls that should only be run by the operating system. What the operating system basically does is in order to protect the system from programs.
I see. So in a typical operating system, when does this switch between user mode and kernel mode occur?
It's happening constantly. It's known as a privilege check. And basically, every time that for example, the scheduler, operating system has a scheduler that's sharing the processor between multiple applications. So anytime there's an interrupt, which will happen on a cycle, or it'll happen when there's an I/O event, the kernel takes control of the processor, and then usually we'll switch to another process or another thread. So there's constantly switching between user mode and kernel mode.
And when these switches happen, what is the performance penalty?
Yeah, so there is I don't know the actual numbers, but there is a performance penalty from switching between user mode and kernel mode. It has to do with privilege check on actually every kind of operation, every system call that's going on from the application. So there's an overhead going on with those privilege checks, and also with the context switching that happens.
So with that in mind, what is a unikernel?
Okay, so unikernel, best way to describe a unikernel, it's a custom library or a custom operating system that's basically designed specifically for a particular application. And further, the way that most unikernel implementations like RumpRun, RumpRun, Mirage work is that they combine the operating system and the application into a single binary that runs as the only executing binary on the system. So the binary has 100% access to memory, and it only runs a single process.
So the other definition I have seen on the UniK wiki was a unikernel is a lightweight bootable disk image.
Yeah.
So how does this idea of a lightweight bootable disk image, how does this differ from a normal binary executable file?
So a binary executable file, you're going to run that on top of some kind of operating system, because a binary typically doesn't have drivers and so on that's necessary in order to run directly on top of hardware. So you compile a binary, it'll be like a Windows executable binary, a Linux executable binary, that basically the application code is there, but not the system code. System code is in the operating system, and the two are connected. The operating system has a runtime installed in it that allows it to run binaries.
So what are some of the advantages of using these unikernels?
A unikernel is it's a fundamental shift from the way we currently do computing. Since the days of shared mainframes, we've gotten accustomed to multi-user, multi-process operating systems, and everything is sort of built on this Unix, Linux-esque world, where we're expecting processes to run in parallel. We're expecting maybe multiple users to share the same machine. I mean, that's actually not typically the case anymore, but it's still a feature of the OS. And basically, we have these generalized operating systems, and we've built our software over the last however many years, 40 years, that's designed for this kind of ecosystem. So we built all the security around applications. We've built a stack that can. We basically, I would say in a nutshell, what we've done is we've created containers as a way to facilitate a multi-tenant, multi-application environment that exists on the OS level, when at the same time we want our applications to run in isolation from each other.
And one example of like wasted. So the way I think about it is like there's all this wasted code in many operating system instances. For example, if you boot up a virtual Linux server on AWS, it gives you a USB driver, and it might give you a floppy driver, and like you don't even have physical access to the machine. Why would you need a USB driver? Why would you need a floppy driver? So how much wasteful code is there in these type of operating systems that are basically
So
crufty.
before I get into that, Jeff, I just want to finish my statement about what I see as a paradigm shift. So I really see us moving from this world where the cloud and where distributed computing currently resides, and I see a yearning there for us to move past, which is where containerization comes from. We want to run our applications in isolated environments that are trimmed down to only give us what the applications need. That's essentially what a container is. When you build a custom container, a Docker container, for example, to run your PHP application, you're building into it, maybe you're building it from BusyBox or from a very lightweight Linux distro. You're installing a PHP runtime and then just giving it your application code. And this is supposed to be a shippable, isolated unit in which your code can run. But this isolation, it's happening on an orchestration level, on a software abstraction level. And what unikernels promise to do is bring this isolation down to the machine level itself, so that the smallest amount of code necessary in order to isolate and run applications.
Okay, so do you have any idea for how much of the machines that we're currently spinning up, like how much of that is wasted on software that we don't actually need?
Right. Well, the idea, again, goes back to running a general purpose operating system in order to run a specific kind of application. Depending on the way a company or user makes use of virtual machines, they may be optimizing as much as they can their usage of the kernel. They may be leaving very large portions of it unused. There's certainly always going to be drivers that aren't used, libraries that aren't used, especially if you consider the way people are running today with containers and Docker. There's a very large amount of the operating system that's not being used with certain distros, which is the problem that companies like CoreOS and Rancher have tried to solve by building specialized versions of Linux. But they're still running with the Linux kernel, which again has quite a bit of bloat in it. That's, I would argue, is far more than necessary to run a simple TCP server.
And one of your colleagues has said that the kernel has become bloated because we are trading off efficiency for compatibility. Can you explain what is meant by that compatibility?
Can I ask who is the colleague? Is that Edith?
Yes.
Okay, so I just want to mention my team. So the work would not have been possible without all three of us. There is our engineer who works out of Israel. His name is Yuval Kohavi. His GitHub handle is UVGroovy. He's been responsible for a large amount of porting rump run in order to work on various environments, fixing and merging support for Go running on rump run, and a lot of other features, components of UniK. But a lot of the low-level systems integration was his work. And of course, Edith is our manager, our boss. She's the inventor of UniK, and there are a lot of talks available online, and then she gives at various conferences discussing unikernels and our project. So you're referring to her blog, I believe, which is on the wiki.
Well, I was referring to her YouTube video,
Okay.
where it was a YouTube video that was linked in the UniK GitHub wiki. But I think my question was actually pretty much something you had already answered. You trade off between efficiency and compatibility because you're building off of the Linux kernel, and the Linux kernel is widely compatible with all kinds of things. It's very easy to build off of. But because you are making your operating system compatible with so many outdated notions, that it becomes less efficient as those overall paradigms have changed, as those notions have changed.
Well, in her talk, I believe she's referencing the fact that as we made decisions over the years of how to build our operating systems, we leaned towards compatibility. We made a choice between, instead of being hardware specific, platform specific, or application or language specific, we built out Linux and other Unix operating systems to support as much as they possibly could, which has led to a bloated kernel. And I think at this point we can now take a look back and wonder if this is the right operating system. This is the right context for running our clouds. If we're talking, about or also embedded devices is another.
Certainly. So as we move to talking about unikernels, with a unikernel, the developer who is using the unikernel gets to select the minimal set of libraries that are needed for the operating system.
That's correct.
So explain how this works. Like, if I'm a developer, do I literally have to choose the libraries that are associated with the application that I want to run, or does it get chosen for me? Explain how this works.
That's a good question. And the answer to that is it's dependent on the unikernel. So currently, at the time of this conversation, UniK is integrated with two unikernels. That's OSV and RumpRun. Now, RumpRun and OSV are both what are described as POSIX-ish unikernels, which means that they can actually take a POSIX compliant application that's making system calls to a regular POSIX operating system, and stub them and redirect them so that they can actually you can take the same application that will compile to a Linux binary and run it as a unikernel on the OSV platform or the RumpRun platform. So in the case of OSV, those libraries are already built in. In the case of RumpRun has a specialized C compiler that dynamically analyzes code and pulls in the relevant libraries at compile time. So you as a developer do not need to know ahead of time what system libraries your application will be dependent on, which is why we think, our team thinks that RumpRun is one of the stronger unikernel, probably the strongest unikernel implementation out there right now. And it's why we've chosen to put most of our effort into supporting that unikernel. That being said, I'm sorry. There are unikernel implementations such as Mirage OS, which Docker has been playing a lot with lately, which does require you to specify and build your application explicitly using the system libraries that you wish to include in your application.
I want to take a step back. Can you define the difference between a unikernel and a library operating system?
I would just say that the library, it really depends on where you look. Some people use the terms interchangeably. What I would say is that a unikernel is a compiled operating system plus application, library operating system plus application, where a library operating system are the libraries themselves or the tool chain for building a unikernel. So, for example, Mirage OS is really a collection of different system libraries written in OCaml. So I can take an OCaml application, hello world, and it's going to listen on a TCP socket and reply with hello world whenever it gets a request. So this is so the library, the TCP library I import, that's part of the library operating system, where it's like operating systems as a library. So I have my TCP stack, it's a library I import into my application, rather than expecting it to be there, as part of the operating system running the application.
So let's start to talk about some of the advantages of using unikernels.
Sure.
What are the different kinds of savings that we get by using unikernels?
Well, there are a few that I'd mention right off the bat. So if we're talking about utilization, let's take our data set there. I've got 5, servers sitting in my data center, small little startup data center. I got 5 servers sitting in there, and what I decided to do is go with a container-based solution. So what I do is I'm running some kind of hypervisor on there, like maybe OpenStack or vSphere for a well-funded startup. And what I'm going to do is I'm going to create a 100 gigabyte virtual machine, 100 gigabytes of disk, 100 gigabytes of memory, or whatever, some fixed allocation of resources. And then my actual applications are going to be running inside of containers. And so I think of each virtual machine as a bucket. And I want to fill the virtual machines up with containers. But there's, by necessity, some portion of those machines I'm not going to be utilizing, which means that when I create a new VM, in order to place containers into it, I'm reserving portions of the underlying servers that are not necessarily in use. So with the unikernel, since they're running as virtual machines, you don't need to reserve system resources to make these buckets. The hardware itself becomes the bucket. Does that make sense?
It does. Can you talk in perhaps like can you give numbers or give some proportions to how much savings, and are we saving disk? Are we saving memory?
Well, we'll be saving all disk memory and CPU, as well as network throughput. Um, I don't have numbers for you. I wish I did. UniK itself is more of an experimental proof of concept type of project. I would not argue that UniK is by any means the fastest unikernel implementation out there. We add a bit of orchestration on top of rump run and OSV, which do increase the memory size and have a performance hit on those unikernels. But our purpose was to make unikernels function in a similar way to how Docker containers function. That you just get up and go and run, and sort of seamlessly deploy applications as unikernels. So that was the trade-off that we took there, and I don't really have numbers for you. I do believe that there are projects out there that have benchmarked boot times for unikernels, memory footprint, etc., but I don't have that actual numbers I can give you, unfortunately.
Sure. So we were talking earlier about how the context switching between kernel and user space is quite painful. Now that we've talked a little more about unikernels, can you contrast what the notion of how are we still doing some sort of security check or something, or like how does that notion change when we move to unikernels?
So in the unikernel, in implementations of rump run and OSV, there is no privilege check going on, which means that every application, or the one application that runs as the kernel. There have actually been some comments online.
Single address space.
Yeah, single address space, single process kernel that runs in kernel mode. There is no user space unless you were going to implement it yourself as part of your application. So everything that happens in the unikernel is on the application level itself. If I wanted to write an application that ran code, arbitrary code, and then when it ran it ran it in some kind of protected space, then that would be similar to the way that Linux works, and Linux separates user space from kernel space. But by convention, this isn't a part of any of the existing unikernel implementations. Now, there are a few blogs that I've seen out there. There's the very, if you're in the unikernel world, you're familiar by now with the Brian Cantrill attack on unikernels from Joyent, which interestingly is now a paid advertisement on Google. If you search unikernels, first thing you'll see is this unikernel smashing blog from the Joyent guy. And one of the things he says is that unikernels are actually less secure than running containers inside of a Linux or inside of a Unix operating system, because the application code inside of a unikernel runs in kernel mode, and there's no this protection. But I think that article is extremely, extremely biased. The whole point of user mode and kernel mode is to protect the system from the application. So you have multiple applications running that are dependent on the system, and you want to make sure that if an application is doing an exploit, or there's a bug, that it only threatens itself, and it doesn't threaten the underlying system. Well, a unikernel, the application is the system. So it just doesn't logically make sense. Why would you have separation between a thing and itself? The application is the kernel.
Actually, I had a listener who I polled the listeners for some questions, and one listener, my friend Dan Osipov, he said that the Brian Cantrell argument also states that unikernels are kind of unfit for production because they're not debuggable. And like the common approach is to, if you have a bug, you just restart the unikernel without understanding the error. Is this like an unsolvable problem, or are there tools to improve the unikernel debugging that are coming?
It's really, I really have to take a shot at this article because it's just patently untrue to claim that unikernels are undebuggable. It may be true that the number of tools available to debug unikernels are much fewer than the tools available to debug Linux or Docker containers. But if you look at Docker containers, 5 years ago, or they're not even 5 years old, 3 years ago, they had the same problem, which is where companies like Sysdig and other monitoring, metrics applications came from. Unikernels are just a very new space, and there isn't a lot of tooling around unikernels. There are hardly even any unikernel implementations out there. You can go to unikernels.org, and you'll literally find a list about 5 or 6 different unikernel projects, most of which aren't even in active development. So I think it's disingenuous. Rump Run includes a rump control application. The rump run toolchain allows you to connect to a running unikernel, run ipconfig, netstat, other debugging utilities that we're used to in the Unix stack. OSV has an even more robust debugging tool. It's just a question of having to re-implement these tools in the unikernel ecosystem, and it just hasn't been done yet. There's nothing about a unikernel that makes it undebuggable. It's just patently untrue.
Can you explain? So, this is not a Valleywag style podcast about gossip, but this area of the competition among different providers and containers and these low-level systems, I have a whole lot of trouble understanding the business models across these different companies and how they contrast. Can you explain why Brian, who is, I think, the CTO of Joyent, which was recently acquired by Samsung, can you explain why he would be motivated to take a shot at unikernels?
All right. So first, let me preface this by saying that these are my opinions and not the opinions of a EMC corporation in any way. My interpretation, to be honest, I'm not super familiar with. I can only give an outsider's perspective based on speculation, but what I know about Joyent is that they years ago they were in the VM market and containers started to emerge, and they fought the container emergence, and they made the same arguments against containers. The containers were not secure. I believe they actually still make that argument against Linux containers. If I understand correctly, they're not running Docker. I believe they're running a container, so their own container solution built on Solaris zones or BSD jails. I'm not sure which are. They're alternatives to the Linux containers that we're familiar with. That I guess they're supposed to be more secure. There's more virtualization going on. They're somewhere in between a full-on virtual machine and a Linux container, which is basically just a process that can't see other processes. As far as what their motivation is in attacking unikernels, I guess they would have to have some financial motivation because he didn't just write an article smashing unikernels. He wrote 2 articles smashing unikernels, and is currently paying for one of them to be an ad on Google. It's probably the first ad ever paid for related to unikernels. But I imagine that he perceives it as some kind of threat. I think that we are quite a ways away from having production-ready unikernels. I think that he's right that it's not ready yet. But there are people who still say Docker is unfit for production. Google that, and you'll find a lot of stuff out there. And I just attended DockerCon a few weeks ago, where I could rattle off a list of companies to you that are running it in production. So regardless of what some people feel, when new technologies emerge that promise tremendous benefit, eventually customers will come out and say, I want to run this. I actually want to run it in my data center. And what do I need to do to get that happening?
Life is too short to have a job that you don't enjoy. If you don't like your job, go to hired.com/SEdaily. Hired makes finding a new job enjoyable, and Hired will connect you with a talent advocate that will walk you through the process of finding a better job. It's like a personal concierge for finding a job. Maybe you want more flexible hours or more money or remote work. Maybe you want to work at Facebook or Uber or Stripe or some of the other top companies that are desperately looking for engineers on Hired. You deserve a job that you enjoy because you're someone who spends their spare time listening to a software engineering podcast. Clearly, you're passionate about software, so it's definitely possible to find a job that you enjoy. Check out hired.com/SEdaily to get a special offer for Software Engineering Daily listeners. A $1,000 signing bonus from Hired when you find that great job that gives you respect and salary that you deserve as a great engineer. I love Hired because it puts more power in the hands of engineers. Go to hired.com/SEdaily to get advantage of that special offer. And thanks to Hired for being a continued longtime sponsor of Software Engineering Daily. And it seems like these arguments aren't usually based on substance as much as just some deep-seated fear. It's almost like, when Amazon, when Amazon came out, when Amazon started getting, Amazon Web Services started getting really robust in terms of security, you still today have people saying, oh, it's not secure, it's in the cloud, what do I know about this? Or Barnes & Noble would be not Barnes & Noble because I think they actually do run on Amazon, but you have a Home Depot or somebody saying we can't do our commerce on Amazon Web Services, it's dangerous. Just these strange arguments. Anyway, okay, we should get back to unikernels. So unikernels have been around for a while, just like Linux containers have been around for a while, and But as Docker has popularized Linux containers, it seems like similarly there's some sort of resurgence of unikernels, or they're becoming more popular, becoming more usable, or something. Can you give me some history of unikernels leading up to the present? Explain why this more recent hipster movement has been happening with unikernels.
Unfortunately, I'm not great on the history of unikernels. There's a great talk by this guy, Ian Iberg, who is part of a small startup called Defer Panic. You may have heard of them. They have they're trying to make a sort of an AWS for unikernels. It's at deferpanic.net. Anyway, so he's and Defer Panic did a lot of the work to bring Go support to Rump Run, which we use as part of UniK. He has a talk that goes deep into the history of operating systems and the unikernel, which is from OSCON earlier this year. I know the slides are available online. I can send you them later on, but personally, I don't know a tremendous amount about the history. What I can say about the popularity of unikernels is I think we're at a time right now when unikernels are just highly relevant. They promise to bring a lot of benefits to the currently existing ecosystem, which is a world of distributed applications running in containers running on commodity hardware, and we're at a point now where we don't really care about the server; we care about the application. And you have all these tools like Vagrant and Chef and Puppet, which say, look, your server is just something to be made and thrown away. Don't get attached to it. It's the application you care about. And unikernels have a lot to offer in this area. When you think about no longer provisioning a server and then configuring an application, but simply compiling a server out of an application. The server becomes a compiled piece of code that can just be deployed directly without any configuration, any provisioning.
As I understand, there are some security benefits of unikernels as well. Are you familiar with those?
Yeah, well, the promise or the potential security benefits of unikernels are tremendous, simply by nature of the fact that a unikernel only contains the specific libraries and drivers that an application needs to run. So it's the minimal subset of whatever an application needs. There are a number of benefits to this. Also, before I get into those, also remember that an unikernel runs as a single process, a single address space, which means it makes it a lot harder to execute arbitrary code in a unikernel. It's still possible with a buffer overflow, but there is no fork. So you cannot execute another application or start another process from a unikernel, which shuts down one of the popular avenues of attack with the shellcode exploits, because there's no shell.
So if I have some IoT application, like let's say I've got an internet connected refrigerator, it might make sense for the internet connected refrigerator to run on a unikernel so that my fleet of refrigerators can't all be hacked and used for strange purposes.
Absolutely. I like to use this example because it's comes from personal experience. But at my old company, and I won't give a name, I worked at a company that built wireless speakers, and these speakers were their own had an embedded device in them. They connected to your Wi-Fi, and you could stream music from them over Wi-Fi, and they connect to your router as an actual device. You don't have to plug them into anything. You just turn them on and control them from your phone. And working this company, I learned that these speakers actually have Linux running on them. And if you want, during debug at work, we would regularly SSH into the speaker. And it's kind of a scary idea when you think about somebody SSHing into your refrigerator, into your speaker, and suddenly having access. Now, that's an additional point that you have to protect against. And basically, with the unikernel, there is no SSH. There are all of these, SE Linux or AppArmor, all of these security features that Linux has built into it to protect the security vulnerabilities that are there. Unikernel doesn't have these vulnerabilities unless you actually actively elect to include them. Unless you say, I want to build an application that has SSH as a part of it. So fundamentally, in theory, you could almost build an entire new Linux as a unikernel if you wanted to, which is why I say that they're lightweight. I mean, they're as lightweight as your application. But the point is that, if in the most common use case, any sensible use case of running a unikernel, you're going to want to run some subset of what's available in a general operating system. And usually that subset in a toaster or in a refrigerator is not going to include something like SSH or running an SQL server, something like that.
No, that's so great because this Internet of Things security stuff is quite a big deal. I've seen all these hacker news. There's these hacker news posts that come up every couple months where it's like, I stayed in a hotel and I hacked the light switches, and it's like I made all the light switches on the floor below me switch off and on rapidly. It's like, oh my God, I don't want to live in this world.
Yeah, it's very frightening. And also when you think about privacy concerns, it's not just hackers that are looking to analyze and get access to our devices, but it's also advertisers and other companies that want to just collect our data. And the opportunity to do that is so much larger when you've got the large attack surface and all the nooks and crannies in a system like Linux.
So could you, I mean, now that we've talked about unikernels in detail, we should talk about UniK, which is the whole reason I'm having you on the show. I mean, obviously you're an expert in unikernels, but UniK is something that you're actually working on. What is UniK?
So I should preface by saying I'm not really as much of an expert on unikernels as the people who have actually built unikernels, because UniK is not a unikernel. Also Yuval, who unfortunately couldn't be here for this, is also like much more familiar with the internals of unikernels, how they work. I've built up a lot of my knowledge through having to defend unikernels from their detractors. But I do know a fair amount just from my experience. But somebody from the Rump Run project or from Mirage would probably be better at answering some of the questions that you've asked about them. I hope those people would consider me having done justice to.
Well, this is the first show I've done on unikernels, and it's clearly something that I'll have to do more shows on. So I think it's almost a feature rather than a bug.
Sure.
That you're not super familiar with the in-depth internals of them and the history.
Okay. Sure. So
UniK.
Yes, UniK, right. Okay, so UniK, this concept came from Edith Levine, and basically she looked at the unikernel ecosystem. We're trying to understand what is it lacking, under basically coming to see very quickly the benefits of unikernels over the current ecosystem, and that the current ecosystem could make this migration to run on a unikernel ecosystem rather than containers, which is where it's headed right now. And what are the roadblocks there? And basically they stood out fundamentally as two major roadblocks. So one of which is the ease of use. Running a unikernel yourself manually is quite a difficult task, even though projects like OSV and Rump Run have tried to make it easier by automating the selection of libraries, that the OS libraries that get put into the unikernel. They're still not quite that easy to, when you compare that to a Docker container, where literally somebody who's maybe knows a little bit of front end and not much else can actually spin up a Docker container with Node.js and start developing backend applications pretty quickly. Nothing like this exists even remotely for a unikernel. So they're very difficult to use for the average developer. And also the ability to orchestrate them is just not there. If you wanted to run a distributed application as a set of unikernels, doing that manually would be a very, very arduous task. So we set out to solve this problem, and basically to create a platform into which any existing unikernel implementation, Mirage OS, Rump Run, OSV, ClickOS, etc., could be integrated. We wanted to have one platform. It's basically like a Docker for unikernels. That would make it easy to automate building and deploying unikernels on any platform with any kind of unikernel, any language, etc.
So how does compiling my application to a unikernel using UniK, how does that process compare to putting an application in a Linux container with Docker?
Yeah, so fundamentally they're different because when you build a Docker container, essentially what you're doing is you're running a shell script, or I think it's Python, or they might have moved it over to Go. But basically what you're doing is you're taking a file system. If you're familiar with the chroot, it's like rooting to a folder, then copying a bunch of stuff into that folder and creating a file system. That's all you're really doing when you build a container. And it's doing it by executing a script. Building a unikernel is fundamentally different because a unikernel is compiled. It's not a file system, it's a single file. You can add files to the boot volume if you want to, or you can attach data volumes if you want to a unikernel. But a unikernel is a virtual machine. A container is a tarball. A container is a set of files and instructions on how to run those files. Containers can run multiple processes. They can run nothing. They can basically it's just a subset of the operating system that's already running underneath it. So when you build a unikernel, what you're building it from, your inputs are sources, or source files, and static files if you choose to have static files included. So you'll take your Hello World application, the actual source files of your application, and with UniK, you tell UniK to build it from the sources, and it'll produce a binary for you. Or actually, UniK itself will produce a bootable image which contains the kernel binary.
So can I use Docker with unikernels somehow? What is the synergy there?
It's interesting that you asked that because Docker themselves are trying to explore this possibility. I don't think that they've invested a lot of resources in it, but there is a project out there called the Docker Unikernel Runner, which, in my opinion, it's kind of like a hacky version of UniK, or parts of UniK. It doesn't actually automate the building. You still have to build the unikernel yourself, but it will run a unikernel for you through Docker, so that you can say Docker run, and the container then hooks out to the host operating system and runs a unikernel in QEMU or KVM. It allows you to, in this roundabout way, like go into a Docker container, and then the Docker container goes back out to the host and says run a container or run a unikernel.
So that's the present day situation. Can you hypothesize about what are there fundamental advantages to using Docker together with unikernels that you can imagine?
In its current incarnation, I would say it doesn't really make sense. You couldn't take a Docker container and run it as a unikernel. Because remember, a Docker container is just a file system. Right. You could intelligently say, okay, so I have my Hello World container, and it's got files X, Y, and Z. And when I say Docker run Hello World, it launches the Hello World binary. I could now create a way, basically turn that into a unikernel manually and say, all right, I'm going to compile a unikernel out of my Hello World and then put files X, Y, and Z on the boot volume. And it'll work in fundamentally the same way, but there's no clean translation, especially when you consider that a lot of unikernels or a lot of containers out there are running multiple binaries, which a unikernel cannot do. And they're also assuming that the Linux kernel exists, which a unikernel also doesn't do.
So tell me so if I have a Docker container, it would not make sense to say, hey, let's look at what libraries this Docker container uses, spin up a unikernel with the minimum libraries needed to support all of the programs in this Docker file system, and run it on the custom unikernel that works for this container. That would not necessarily make sense. Well, it sounds like the big gating factor is just that, or well, maybe it's one, that the introspection is not good enough, but two, maybe it's that you need to run multiple binaries sometimes. I don't know, maybe you can tell me where that falls apart.
Sure. So actually, you could absolutely take many of the applications that are being run today in containers and convert them into unikernel. It can definitely be done, not by an automatic process, at least not today. This is something we've talked about, is trying to basically take a container and convert it dynamically into unikernel. That in itself, it requires an in-depth knowledge of how the application actually runs. So it would be the application creator, the person who made the container for the application, could then go, using the source code for the application, create a unikernel to do it. It wouldn't be a trivial thing to just convert an existing container file system into a unikernel. That being said, most applications, you think about this, the world of quote-unquote microservices. It's a term I really can't stand, but the way people are designing their applications these days is to be single binary single process applications that are just running, whether you're running like a Tomcat or Apache server for some of the more traditional workloads that are out there, or you've written, a very clean application in Node.js or Go, and it just executes, it's just running a long-running server, handling requests. These things make a lot of sense for unikernel. And right now they're being run inside of a container. If you go inside, if you SSH into one of these containers that's running like my Node server, and do a PS, all you'll see running typically is just Node. That's it, and maybe init. In those situations, it absolutely makes sense to run as a unikernel, and I would argue more so to run as a unikernel. If you're basically taking your shell, I mean the shell is a really good example. You're going to take sh or bash and try to run that as a unikernel. It'll never work because the way those things work is they fork. They execute sub-processes. So if you want to do Docker run Ubuntu /bin/sh, which I do that all the time, that paradigm doesn't make sense in the unikernel world.
Okay. So, as we begin to draw to a close of this conversation, to bring this home, so you work at EMC, and EMC is heavily invested in Cloud Foundry. And in that talk I saw by Adit, she talked about the advantages for the typical Cloud Foundry user in a world with unikernels. Just to bring this conversation home, can you explain the kinds of savings and the kinds of advantages that a typical Cloud Foundry stack would get out of having a base of unikernels?
Sure. So again, going back to my example of if we're talking about like cost savings, just for the heck of it. Going back to my example before about the buckets. So right now, what Cloud Foundry does, Cloud Foundry runs applications in containers. The containers themselves are run inside of workers, basically. So when you spin up a Cloud Foundry deployment, you specify I have this number of controllers, I have this number of masters. There are all these different components that are virtual machines that are part of your deployment. But then you have some number of virtual machines, and these are the really big ones, the bulky ones, where the applications get run. So you have some number of workers, usually 3 or 5 or 100, however big your deployment is. But the point is that you have to pre-allocate space on top of your physical infrastructure where the containers are going to run. And then if you want to expand, if you want to scale either up or down the number of workers that are available for your containers, let's say you have a surge in demand or demand drops for your application, it actually then means you have to manually redeploy Cloud Foundry, or you not redeploy the whole thing. They have a deployment tool called Bosh that scales the cluster up and down, but it's still something that you have to do external to Cloud Foundry, where unikernels run directly on the metal. So when a unikernel is requested or an instance is requested of an application, UniK, using the UniK integration, UniK will go out to the metal and just, the hypervisor that's running on the metal and just create a new VM for that application. So that's one in terms of resource consumption. Then you've got the obvious benefits of security that we've already gone over, efficiency, applications run with better efficiency, and the other benefits that containers haven't yet gotten to the state of having mature networking solution. Virtual machines have been there for 20 years. Mature storage solution. Virtual machines have been there for 20 years. So all these things that containers are working on catching up to, and undoubtedly will eventually have, virtual machines already have had for years and have basically perfected. You have live migration of virtual machines with something like vMotion on vSphere. Currently not possible with Linux containers.
Okay, so just to ask a final question, we were talking about this before the show started, and you've touched on it a little bit, but Docker recently acquired a company called Uni Kernel Systems. It's a company that makes the Mirage OS and the Zen hypervisor. Why do you think that happened? What are they going to do?
It's an interesting question. So the first thing that they actually did do, and I know that this was a big part of their acquisition, was the Docker for Mac and Docker for Windows. So if you've been following the recent news with Docker, right now I'm running Docker using VirtualBox on my Mac because Docker requires a Windows kernel, or I'm sorry, a Linux kernel in order to run. Because the way Docker runs containers is that the Linux kernel gets shared between all the containers that are running. So it requires Linux. And that's the same way that you ran it up until a few months ago on Windows as well. But what they wanted to do is they wanted to make it so that you could run Docker directly on your OS without having to run VirtualBox or some kind of bulky Linux VM. What they did was they basically made their own hypervisor. So when you're running now Docker for Mac or Docker for Windows, it's actually running a unikernel. It's running a little Linux unikernel. It's not accurate to say Linux unikernel, but it's like a specialized unikernel that is able to provide the Linux containers with what they need in order to run. And so they acquired the unikernel systems people largely to work on that. I believe that's what most of them were working on when they first signed on to Docker. I know it was a big part of their announcement at DockerCon this year. But then, we get into the more speculative areas is what do I think their long-term goals are for the unikernel people. And I have to say, I think that Docker is going to take a look at expanding beyond the world of containers and seeing, are unikernels the future of the cloud? Are they going to run side by side with containers? I think that Docker is definitely interested in this space, and they want to make sure that wherever the technology goes, that the Docker API and the Docker experience is a part of that.
Thanks for prognosticating on that. I appreciate the predictions. And thanks for coming on the show to talk about unikernels. I appreciate having this conversation. Listeners have been asking for it for a while, so appreciate your presence.
All right, great. Yeah, it's been a pleasure.
SafeGraph is building a company to securely monetize exhaust data. If you are amazingly entrepreneurial, you live in San Francisco, and you want to be one of the first 5 employees at SafeGraph, either as an engineer or a business development person, check out safegraph.com.
Wow!